The next recursive function we're going to do is Fibonacci. Here's the calculation for Fibonacci. N is going to equal n minus 1 plus n minus 2. And we're going to keep doing that for all of n down to 0 or 1. So here we have two base cases. We're going to check if n is equal to 0, we're going to return 0. And if n is equal to 1, we're going to return 1. So in this scenario, if we added in 3, the first recursive call should look something like this, but we'll have f3 here is equal to f1 minus 3 would be 2, so it would be 2 here, plus, and then n minus 2, which is 3 minus 2, is 1, so it would be 1. And then both of these would call their own recursive function, so then this would just return 1, because it hits one of our base cases, and then this will equal to factorial 1 plus factorial 0. These would both return 1. So the result for this would be 1, 2, 3. Now let's write out our function. Let's go to the functions.h. Let's write the prototype for Fibonacci. We'll do int Fibonacci, and we'll take in another integer n here for the parameter, and it'll return an integer. Now let's hover over the screwdriver and let's press create definition. Create it in the wrong place. Let's just move it down. So first, let's write out our two base cases. Let's write if n is equal to 1, let's return 1. And then we're going to say if n is equal to 0, we can return 0. So now we need to replicate the equation right here, like how we did above. So here we did n times n minus 1, n times n minus 1. So here we're going to call Fibonacci minus 1 and Fibonacci minus 2. So here, let's do return Fibonacci, and we'll do n minus 1 plus Fibonacci n minus 2. And this should give us the right result for the Fibonacci sequence. So let's go inside of our main function here, and let's write some test cases for Fibonacci. So let's write out printf Fibonacci of, so let's test cases 0, 1, 5, and 8. Let's do all of those. Fibonacci sequence of 0, and then we'll do colon %d expecting, and here we should be getting 0, new line, and here we'll call Fibonacci 0. Let's copy it a few times. We'll do Fibonacci 1, Fibonacci 5, and then Fibonacci 8. So when we run Fibonacci 1, we should expect to get 1. Fibonacci 5 should return 5. And Fibonacci 8 should return 21. And then now let's call it for each. We have 0, 1, 5, and 21. Now let's just add one more printf here for an extra space. Oh, I just realized that we need to put 8 here, not 21. Okay, so now let's run it. Control F5. And we have 0, 0, 1, 1, 5, 5, 21, and 21. So now we can ensure that the Fibonacci sequence does indeed work. One more thing, though, is that we can actually enhance the function slightly. We can combine both of these base cases into one by transforming it to now say if n is less than or equal to 1, and this covers both scenarios 1 and 0, we can just return n. And the reason for this is because we're saying if n is equal to 1, return 1, so that's the value of n. And then if n is equal to 0, return 0. But we could just return n because that means n is equal to 0 and we're returning the same value as n. So here, this is the same thing as these two base cases. So if we delete these, and we do Control F5 again in our main function, we can see that nothing changes, and it's the same thing.